Hi everybody, this is the video solutions to problems 9 through 13 on our Unit 2C review. So the first thing we have is to rewrite, condense or expand the logarithmic expressions. So when this particular one, A, is asking us to expand. Why do we know that? Because we see a single log right here. So what we need to look at is what our expanding properties are. So we'll just kind of recap those. When we are multiplying, it is addition. Expands to addition. When we are dividing, it expands to subtraction. All right, so the first thing we're going to look at is the fact that we have division here with that fraction bar. So I can write that as the first expanding. So I'm going to have the log base 2 of this x cubed y minus the log base 2 of that 15. So again, that dividing changed to minus. Now we're going to expand this first expression, and right there between the x cubed and the y, what you need to realize is that that is multiplying. So to expand that part, we have log base 2 of x cubed plus log base 2 of the y, and then we still have that log base 2 of 15. Now the only other thing we need to do here is, let me go ahead and zoom in on that. Does everybody see this exponent here? What that does, it moves to the front. So our final answer would be 3 log base 2 of x plus log base 2 of y minus log base 2 of 15. All right, so that's letter A. Letter B, notice how it has multiple log terms. So we're going to turn around, and this one is asking us to condense these. So this is going, the property is if I have an addition, that changes to multiplying. If I have a subtraction, that changes to dividing. So going left to right, let's do something first. Does everybody see this 5 in front of that log base 4y? What it does is it moves to that exponent. So we're going to go ahead and write these two together with that exponent. So remember, if I have that plus, this will change to log base 4 xy to the 5th minus, and then this 2 also goes to the exponent. So I'm just going to write that in there. So we have log base 4 z to the 2nd power. Now if you take a look at that subtraction, that's going to turn into our division. So our numerator is going to be the log xy to the 5th divided by that z to the 2nd. So that would be, let's put some equal signs here. That would be those particular log terms condensed. All right, number 10. Now, taking a look at this information you have above, probably the most important thing here is that you need to isolate the log expression. So in order to do that, we are going to use our inverse operations like we learned in Algebra 1. And then we're going to switch it to exponential form, and that is when we are going to solve that. Now, a couple little things to remember. Natural log has base e. And then we could possibly be using the properties of condensing and rewriting. And when we are actually solving, once we have converted to exponential form, remember, if we end up with a quadratic, it has to be set to equal to 0 and you would need to factor. And the other thing we might need to do is exponentiate both sides. And I'm pretty sure we have an example of that. All right, so let's go ahead and take a look at number 10. So ln, we have the natural log. So the way I like to do this is to turn around and rewrite this. Does everybody remember how the ln is log base e, and then we're going to have that argument equal to 2. Now, if you notice, this is isolated. So all we need to do here is convert it to exponential form. So our e is our base. The 2 ends up being that exponent, and then we have it equal to the argument. And what do we need to do? Inverse operations to solve and isolate for that x. So we're going to add 2 to both sides. And what we end up with is e to the second power plus 2 is equal to x. Now we would turn around and put that in our calculator, and we would end up with, we're going to do 2 decimal places and rounding if we need to. So I ended up with 9.39 when you round. Okay, so we always have to realize we need to check just in case our expression in the argument ends up being negative. And I'm pretty sure you can see right here that the 9.39, if it was put into the argument of x minus 2, it would be positive, so we are good to go. All right, next page. All right, so this page we have problem 11, 12, and 13. Now, this first example is when we have logs on one side. So what that still means is that we need to isolate with inverse operations. So to isolate this, our first inverse operation is to take care of that 2. So we are going to be subtracting 2 from both sides. We end up with log base 3 with our argument is equal to 2. Now that we have it isolated, we can convert it to exponential. So in this case, our base is going to be that same base of a 3. The 2 becomes the power, or 3 to the second power, or 3 squared. Oops, I don't need that parenthesis right there. So then we're going to have the argument on the right. Now what do we need to do? Isolate the x. Our inverse operation is to add 1. So we would end up with x is equal to 10, right? Because the 3 squared plus 1 gives us 10. Again, we would want to look at that check. If we were to look at that argument of the x minus 1, we would have a positive number for that argument, and we would be a-okay. All right, example number 2. Here we have 2 logs on one side. So what that is telling us is that we need to condense. And we see that plus. That means it's going to change to multiplying. So at this point, it is isolated. We can turn around and write it into exponential form. We would have 2 as our base. The 3 ends up being that power of the 2, and then we have it equal to the argument. What do we do next? See that x? We need to distribute. And the 2 to the third power is 8. We would end up with x squared minus 2x. Now remember, when we have a quadratic, we always want it set equal to 0. So to turn that 8 to the other side, we would have, and I'm just going to go ahead and rewrite this so that we have this on the left-hand side just to make us a little more comfortable. So what do we need to do? We need to factor this. And that would end up being, of course, when we're factoring, we're finding those 2 binomials, x minus 4 and x plus 2. What happens with that? When we set the x minus 4 equal to 0, we get x is equal to 4. Set the x plus 2 is equal to 0, we get x is equal to minus 2. Now the question is, do they both work? Does one of them work? Do none of them work? Or neither of them? So when you take a look to check this x is equal to minus 2. Well, if you look at the very first term of this, it was log 2 of x. Does a negative work in there? It does not. We cannot have a negative argument. So that one is eliminated. If we take a look at our 4 in both of our terms and our arguments, we are good to go. So that x is equal to 4 is our solution. One more to do. When this situation is, we have logs on both sides. So a lot of times students want to say, oh, they just cancel out. Well, the actual reason, we're going to exponentiate both sides. So really what we have, that's a 3, is this. And when you do that, you always want to have the base that you're exponentiating at the same base as the log. So this is what we would have. Now what you need to realize now is that an exponent, a base of 3 with an exponent of a log 3, that goes to 1. So we are left with the x minus 1. Here's the 3 and the log 3 going to 1. So we're left with the 2. Isolate it, and all we have is x is equal to 3. When I said isolate, I meant solving for x. So we have x is equal to 3. The question is that an okay solution? And the answer to that would be yes, because if we see that argument, we are A-okay. It's positive. We are good to go. All right. So the other thing that we are asking you to do on both 10, 11, 12, and 13, this little area over here, we want you to write some notes to yourself as far as some of the things to remind you on how to solve for these. All right, you guys, any questions, be sure and ask us. See you next time.